Hi everyone. In this video I will be showing you how to read the different onboard sensors on the MXChip AZ3166 IoT device. I will review each of the sensors available and write a quick sample application that you can use to read from each of these sensors. Let's get started. I have here an MXChip IoT device. If you don't have one, please click the link in the description to purchase one. There's also a link in the description to update the firmware on this device. Please follow the steps for this, as I assume you have already updated your device and configured it to connect to your local Wi-Fi network. This device comes with 4 onboard sensors: a temperature and humidity sensor, a pressure sensor, a magnetometer sensor, and an accelerometer and gyroscope sensor. Since this board is Arduino compatible, we will be creating an Arduino sketch that will read from each of these sensors using VS Code. The first thing you want to do is install VS Code and make sure that you have the Azure IoT Tools extension installed. Once you have that, we'll need to create a new project, so hit F1. And type in Azure IoT Device Workbench, and you'll notice that the first selection is Create Project, so go ahead and click on that. And it's going to prompt you now for the name of the project you want, so we'll call it Sensor Test. And it's going to ask you what platform, so you can do Arduino or Embedded Linux. We're going to select Arduino. Now it's going to ask you for a project template. So since we're working with the MXChip device, we want to select one of those. So you can see that there are 3 of them. One for just using the MXChip device by itself, but there's also support for using the MXChip device with IoT Hub or with Azure Functions. So we're not going to use IoT Hub or Azure Functions right now, so we're just going to pick this first one. And what this does here is now it creates a project and a workspace here, which you can see on the left. And it starts you out with some boilerplate code. It starts you out with 4 JSON files, which help determine certain things like what the board is, what the name of the sketch is, and certain other configuration options. And it gives you a device.ini file, which is the Arduino sketch. So now that we've created our project, you'll notice that the Arduino sketch that's been given to us has a setup and a loop method, which are blank, and we can just start coding here. So the setup method is for just once only code. It runs in the beginning, and then the loop is the code that just runs over and over again. So there are a few things that we need to do just in general with this board, and we'll run through those. So the first thing we need to do is we need to initialize the display. So this is going to be in the beginning here, so we want it under the setup method. So we're going to type in screen.init, and notice how we have IntelliSense. So that's going to initialize the OLED display on the device, and then we'll want to print something to it. So let's just print the word initializing. So once we have that, then the next thing we want to do is we want to set up the serial support. So we'll just put something to the screen so that we know that we're doing that. And then now there's another helper class called serial, and we want to say serial.begin. And then what this expects is a baud rate that you pass it. So we're going to pass it 115,200, and that's how you do the serial. And then finally we want to initialize the Wi-Fi. So again, let's print something out to the screen. And Now we're going to use a global flag called has Wi-Fi and set that to false. So let's put that above here. So it's just a Boolean. And then we're going to create a method called init Wi-Fi. Oops. That will do our work for us. So the init Wi-Fi method is right here. And what that's going to do here is it's going to type something on the screen. It's going to initialize this Wi-Fi and check to see whether it's connected. And if it is, then it's going to grab the local IP from the device, print it out on the screen on the device, and then set the has Wi-Fi flag equal to true, and then specify on the screen that it's running. Now you'll notice here that there are red squiggly lines underneath there because it doesn't understand what that is. So we need to add an include file. AZ3166, and you can see there's one called Wi-Fi. So we need to include that. That's part of the library that comes with it. You'll notice now that once we've added this include file, the red squigglies go away, and you can see that it does recognize these classes. And then finally, once we run the init Wi-Fi method, we want to check to see whether or not the Wi-Fi has been set up properly. And if it has not, then we're just going to return out of this setup method. Once we have the general setup of the screen, the serial port, and the Wi-Fi on the board, we can now start coding for the individual sensors that we want to read from. The first thing we need to do is we need to instantiate a helper class that will help us initialize and use the different I2C sensors on the board. So we need to define a helper class of type dev I2C. And you'll notice the red squigglies here. VS Code is telling us that it doesn't recognize what that is, so we need an include file here of of sensor.h. And once I save this, now you'll notice that this turns blue, and it recognizes that this is a helper class for the I2C peripheral devices on the board. Once we have an instance variable of this dev I2C class, we need to instantiate it in the setup method. And we do that by just doing a new on the class and then passing it in. There are 2 pins that it needs from the board. So this will instantiate this class, which we'll be using when instantiating other sensors. So the first sensor I'd like to start with is the temperature and humidity sensor. And in order to do that, we need to create a variable for that sensor. I'm calling it temp sensor, and it's of type HTS221 sensor, which is another class provided for us specifically for that sensor. So once we have that variable, we can now instantiate and initialize the temperature sensor in the setup method. And we do this by creating a new instance of the HTS221 sensor, and we pass it in a pointer to our helper class, and then that instantiates a new instance of that, and then we can call init, and we pass it null. And this initializes the temperature sensor for use. So once we've initialized our temperature sensor variable, now we can put something in our main loop. So what I want to do first is I want to make sure that we have Wi-Fi available. So I know that we're not really using Wi-Fi for reading this temperature sensor, but it's a good practice to have Wi-Fi available when you're running this Arduino sketch, so that you can do firmware updates, over-the-air updates, and communicate with the cloud. So we're going to put that in there. So we want to make sure that the has Wi-Fi flag is true, so that Wi-Fi is available. But once we do this now in order to read from the temperature sensor, what we can do here is we can say temp sensor enable. So we first have to enable the sensor so that we can read from it. So that's what we're doing here, is we're enabling that sensor. And then we can say temp sensor, and we can say get temperature. And this method now is asking for a variable of type float on what the temperature. This is going to put the temperature value into this variable. So now we don't have one defined here, so I'm going to define this in a minute. But we're gonna so let's just do that right now. Basically, then it's going to store whatever temperature it reads into this variable, and then we can print that out to the serial monitor. So only %F for float, and do a line return. Oops. And that should print out the temperature to the serial monitor. Now we can also do the same thing for the humidity. And let's also print that out. Okay. So let's save the file. Now the last thing we need to do is we need to disable the sensor when we're done with it, as well as reset it for the next time. So as it goes through this loop, it's going to turn it on, turn the sensor on, read the variable, read the temperature and humidity, disable and reset it for the next time. Now, one other thing we need to do for the main loop is we want to delay, so that this gives a delay after it runs each time. So there's a function, our method inside of here called delay, and then it asks for milliseconds, number of milliseconds to delay. So I'm going to say 1,000 milliseconds. So it's going to delay 1 second. So then that allows us to delay each time it runs through the loop. So now we're ready to compile and upload the code to the device. So in order to do that, the first thing is to compile it, make sure we don't have any errors. So if you hit F1 and type in Azure IoT Device Workbench, you'll notice that there's a selection for compiled device code. So if I select this, it's going to compile the code, and it takes a few seconds. So once it's finished, you'll notice now that if there aren't any issues, it will say done, and it finished verifying the sketch. So this means that your code is good and it's ready to be uploaded. So once our code compiles successfully, we're now ready to upload it to our device. So what we need to do is we need to plug in our device to our computer. And when we do that, you'll see that it pops up a couple windows. We can just kind of get rid of these. But you'll notice that on the lower right, it recognizes that it's an MXChip device and that it's connected to COM4. In order to upload the code to this device, I can hit F1 and type in Azure IoT Device Workbench, upload device code, or alternately, I can just click on this little icon here to upload this to the board through the COM device. And you can see that the lights are flashing. You can see that the lights are flashing, meaning it's coded. It's uploading it, and then when it's done, now it's trying to connect to the Wi-Fi automatically. And then you can see now that it's running, and it shows our little display. So let's go back to the code. And then if I click on this little plug symbol on the lower right, that's to open the serial monitor. So if I open that up, you can see here now that it's actually displaying the temperature and the humidity data on the screen as it goes. So if I hold my finger over the sensor to increase the temperature, you're going to see it change. And notice how the temperature is going up and the humidity is going up because of the heat from my fingers making it do that. Okay, so now that we've coded the temperature and humidity sensor, let's move on to the other sensors on the board. For the accelerometer and the gyroscope, we need to create a variable that can reference that sensor, which is, we'll call it Accel gyro sensor of this type. And we're also going to do the pressure sensor and the magnometer right away too. So I'm going to put variables for those as well. So pressure sensor and magnetic sensor. I also want to have some variables here for that. So what I'm going to do is I'm going to actually put some variables here in the program. So for the accelerometer and the pedometer, we're going to have a step count that's counting the steps. And then for the accelerometer, it's going to be axis data, so X, Y, and Z. So I'm going to call it X-axis data. It's just an array of 3 integers. And then for the gyroscope, it's going to be G-axis data, which again is an array of 3 integers. The magnometer variables. So basically, I'm going to just have axes here, which again, an integer array of 3 integers. So then now to initialize these, what I need to do here is I need to initialize the accelerometer. So I'll do that here in the setup method by instantiating a new instance of that sensor, passing it our helper class along with the pins that it needs, and then calling the init method. And then now for the accelerometer sensor, I can enable one of the 3 sensors on there. So I can enable the accelerometer, I can enable the gyroscope, and I can enable the pedometer. And if I enable the pedometer, I also have to set a threshold for that pedometer, so we'll just set that to mid-low. I also need to initialize the step count for the pedometer, so I'm going to initialize that to 0. And I'm also going to initialize the pressure sensor and the magnometer sensor. And that's done by creating a new instance of each of those sensors. So the pressure sensor is this one, and the magnometer is this one. And I pass in the helper class to each one of those and then just call init. So once I have those other sensors initialized, I can now use them in my main loop. So in order to do that, so for the pedometer sensor, I can call the getStepCounter method from the accelerator sensor, and then I pass it in the step count variable. So that's going to what the step count is and store it there. And then I'm going to print that out to the serial monitor. And same thing for the accelerometer. So I want to get the x-axis data and put it into this array of 3, so since that's what it expects. And then what it'll do is I'll print it out to the serial monitor, and it'll show the X, the Y, and the Z variables that it has. Same thing with the gyroscope. only it's going to be the get G axes, and that's going to store into that one. For the pressure and magnetometer sensors, I do basically the same thing. So for the pressure sensor, in order to read that, I'm looking at the pressure sensor and calling get pressure, and then passing it a variable for the pressure. Same thing with the magnetic sensor. Now I want to call, I'm going to call the get M axis method off of that class instance and pass it a variable there. And then I'm going to print out to the serial monitor the values of that. Now I don't have pressure here, so let's get that defined. So that's a floating point variable. So let's go back up here. And say static float pressure. And just to clean up the serial monitor to make it a little more readable, I'm just going to print out a blank line in between each set of readings. So once I'm ready now to, I can recompile my code. And once it's done, I can go ahead and re-upload it. And once that's done, you can see that it's on the serial monitor right away. So it connects to my wireless, and now it's spitting out the information. Now you can see here that the temperature and the humidity are being read. The pedometer step count is 0, and then this axis data is relatively unchanged. Let's go look at the device now. So if I actually move the device positionally and then go back and look at the code, you can see now that the step count is 13. I'll move it again so that you can see the axis changing for those sensors as I move things, as well as the step count. I hope this article was helpful in explaining how to read the sensors off of the MXChip AZ3166 IoT device. If you'd like to download the full source code for this example, just please visit my GitHub repository located in the description. Thanks for watching.